Hi friends, welcome to the analyze phase case study. We will divide this analyze phase into two parts. Analyze phase part 1, in which we will discuss about FMEA, failure mode effect analysis, and analyze phase part 2, in which we will discuss about graphical and statistical study. In analyze phase part 1, we are discussing FMEA. FMEA is basically analysis of risks of the causes which we identified in process flow diagram and then shortlisted in our cause and effect matrix. The basic purpose of FMEA are twofold. The first is it allows us to identify the causes which are causing major issues in X, also called as spatial causes, and our ability to take actions on them. The second purpose is to categorize X's based on three criteria. The first criteria is severity, which is how bad is the effect of a particular cause or X if it goes wrong. The second is occurrence, that means how often it is happening that X goes wrong or moves out of the specifications or desired conditions. And the third is detection rating, which is actually how good is our control over X so that it does not convert into or does not go or does not fail. That is what is the detection rating. Based on these three criteria, it helps us to categorize which X are more critical and which X are less critical. The key difference in the process FMEA that we make for process design and that we make for Six Sigma project lies in the severity scale. The severity scale in a Six Sigma project is based on the primary metric or the objective of the project on which it is going to make an impact. For example, in this case study, the objective is yield, which is presently 36%, and the objective is to take it to 42%. Now, team converts this 36% into equivalent value or into equivalent liters or equivalent quantity which can be perceived in an event. So they multiply it with the batch size, which is 40 kiloliters, and they get 14,400. Same way, the target is 42%, which is equivalent to when multiplied by the same quantity gives a equivalent value of 16,800. The difference is 2,400, and this 10% of this difference is considered as the rating of 10. 9% of this difference is rating is 9, and therefore the scale is around, the severity scale is around, if X changes and if the impact is of 1%, the rating is 1, and when the impact is 5%, the rating is 5, or it is 10% or more, the rating is 10. Let us see how the team proceeded about FMEA. They first took the first step, which is cleaning the vessel. And in cleaning the vessel, they found two characteristics, which is skill of cleaning and the pressure of the liquid by which they are cleaning. So while skill, the requirement is the skill should be L2 or above. The failure mode is when somebody less than L2 skill is operating or trying to clean the vessel. Now, what can be the effect? So if less than L2 skill level person is trying to clean, he may miss certain critical steps, and if he misses the critical steps, there will be leftover which will result into yield reduction. But how much yield reduction? The team estimated it is about 200 liters, which is 8% of the project delta, which was 2400 project delta. And therefore, they gave the rating of 8. Same way, when we talk about cleaning pressure, the cleaning pressure, whenever reduces from the specified level, it is called failure mode. Now, when it reduces, the entire material or the previous leftover material is not removed because of the low pressure. And again, the team found if this is not removed, the yield is lost, which is again about 200 liters. And which is 8% of the project delta, and again rating of 8. And this way, team keeps on giving understanding the effect, quantifies it, and give the rating according to the quantification of the impact. So once the team has finalized its severity rating, it now starts exploring the causes of failure mode. And in this case of low skill, the team identified the cause was that low skill person was deployed because the person of required skill was not available during absenteeism. Why during absenteeism the skilled person is not available? Because there are only 3% who are trained in this, and therefore this is happening every time a reliever has to come, and the occurrence rating of 6 is given because this is happening very often. Now this rating is given based on AIG scale, which is trained in detail in our FMEA course. Anybody who wants to join can join our FMEA course and understand AIG scale. Post this, we try to understand what is the present control, how it is trying to control the cause or the failure mode or the effect. Presently, the shift schedule is made such that the person of required skill is available. But whenever reliever is coming, which randomly is coming often, is the person is not available, and therefore it is the rating of 9 is given with respect to detection rating to this control mechanism. Again, the AIAG scale is used, which we can learn from our standard FMEA course. Now, when you multiply severity, occurrence and detection, what we get is called as risk priority number. The risk priority number is very useful in categorizing the axes or the causes, which we will discuss in subsequent video. And also the recommended action, which is now very important part of the FMEA, is seen. We first try to see if we can actually act on X or cause of the X. If we are trying to act on the cause of the X, we should have more people trained, and that is the recommendation. And the team trained more people and was able to come out with this problem of people for not available for cleaning. Now, same way it is analyzed for low pressure, and they found the low pressure is because nozzle is not being cleaned of scales often, and they found there is no control, and the recommended action again comes for putting it in PM and maybe indicator for pressure drop. So this kind of actions keep on coming, and we see 20-30% improvement in our process even during FMEA. Now we have come to the stage where we can use FMEA for classifying all the axes into 3 categories: top, middle and bottom category. Now the axis with severity rating more than 6, which is 7, 8, 9, 10, whatever with our RPN rating, it is considered as top category or top X, top bucket X. In this case, we can see 8 such X's are there, where even RPN rating, whatever with RPN rating, the severity rating is more than 6. Now we come to the ones where severity rating is less than 7, but RPN is more than 300. Such cases are also considered for top bucket, and 12 such cases the team has identified in this project. Then if the severity rating is less than 7 and the RPN is between 125 to 300, it is considered as middle bucket X. Any severity rating less than 7 and also RPN rating less than 125, we classify it as lower bucket X. What do we do with this categorization? The top axis, which is 20 axis, are considered for graphical and statistical study, which we are going to do in our subsequent video. The middle bucket axis, which are 46 in this case, will be considered for immediate action, and immediate action on this will result into significant benefits to the project. So about 20-30% change you can see in your primary metric just by appropriate actions on this middle level axis. Then comes the lower bucket axis, which are in this case about 135. We see that we have to check the controls of these axes, so that whatever present situation we are able to manage with, say for example, let us say present yield of 36%, it is because of these controls, and therefore these need to be checked that they are well in place. This brings an end to our analyze phase part 1 video, which is on failure mode effect analysis. Please give your feedback so that we are able to improve on our subsequent videos, as well as bring more relevant videos which are liked by you. Please subscribe our channel so that you get notifications on whenever new video is launched. Thank you very much.